Hi, students. Welcome back to the fourth and thankfully final problem in the homework set. This is the DC circuit set. And if you've watched the previous videos, the problems got harder and harder, and this one certainly is going to be, I think, the most complex. Notice that it is it's a kind of a complex circuit here, and it's drawn in a funny way, right? And this is how electricians and electronics experts will draw these circuits sometimes. But notice that this and this are exactly the same, right? This one looks more familiar to us because we can see that these two are in series easily, and these two are in series, but that these two are in parallel to these two. And it's easy to see here, and it's a little bit harder to see here. So I've just redrawn it. This is just the same thing as this diagram here, which is what you were given. And again, what we're trying to find is the current going through each of these resistors and the voltage going through each of these resistors, the voltage drop across each of these resistors. All right, so here we have a 3-volt source, and notice that the positive end is this way, so the current is going to flow out this way. So this is going to be what we call IN. This is going to be the input voltage of our current, input voltage. This is going to be, it's been a long morning. This is going to be the input current into our circuit. Okay, I'm concentrating now, and now we'll go. All right, and notice that this part here and this part here, we'll call this A and this B, okay, is the same as here, B and A. All right, so the current is going to hit A and it's going to branch, and there's going to be a current that goes this way, and there's going to be a current that goes this way. And I'll call this one I-60. It's going to get really complicated, right? There's so much to draw. And this is going to be I-80 because it's going through the 80 ohm resistor. And this one here is going to continue this way, and it's going to be I-70. And I-70 and I-80 are the same thing. Because, in fact, what I may do, you know what? I'm going to do this. I'm going to call this, what did I call it before? Let me pause here and look at my notes so I don't confuse myself. Yeah, I did the same thing. I called it I'm going to call this I-7080 because it's the same current that goes through the 80 and the 70 ohm resistor. So I'm going to call this I-8070. Okay, and this I-60 is I'm going to call I-6050 because it's the same current that goes through both of these. It doesn't branch. So this is going to be I-6050, 60 first and then the 50. All right. So this current here is I-5060 or 6050. And this current down here that's going to flow through these two is I-8070. Okay, and again, the current that comes in is IN. All right, so now we've met all the players. I guess we haven't met the voltage drops. We also want to figure out what the voltage drop is across each resistor. So imagine you have a voltmeter here. I'm going to call it V50. And that's the voltage drop across the 50 ohm resistor. And I have a V60, here, and I also have a V70 and a V80. I'm not going to draw it because it's getting complicated. But voltage drops and the currents through each is what we're looking for. All right. So just like before, we have to take our circuit, and which is complex, we have to make it simplified. So we see. And this just takes some practice, but look at it and notice that the 50 and the 60 are in series with each other. And the 70 and the 80 are in series with each other. So let's take care of those two first. You might think, oh, why can't we do the parallel? Because even though these two are parallel to these two, we really want to only have one equivalent resistance here. So we're going to take these two and we're going to compress it down into what I call R5060, okay, which is the equivalent resistance of these two, which is 110 ohms. And if you don't remember, these are in series, and so resistors in series simply add from the equation sheet. If you can't remember that, they just add up. 50 plus 60 ohms is 110. We do the same for the 70 and the 80 ohm resistors. They add up to be 150 ohms as shown here. Okay, and now what do we do here? So now we have two resistors that are in parallel, and now we can simplify that down to RP, which is 63.46 ohms. And if you don't remember how, remember resistors in parallel, they add like this. Again, once again, sorry, it's a broken record. What you're calculating here on the right-hand side is not RP, it's 1 over RP. So you have to invert your answer. And as shown here. Okay, so my resistance is bigger than 1 rather, so I'm happy with that answer, and I'm double check my work as I go, and I'm pretty confident that what I've done so far has been good. I've labeled the steps 1, 2, 3 here, and we're going to have a whole bunch of steps. We're going to end up with 10 steps in this problem. Okay, so step 4. Let's go ahead and jump right in. Step 4 is going to be to calculate what we don't know here. Okay, what we don't know is the current going through RP. Okay, and that is just IN. That's the current going into the circuit. Okay, because this dot and this dot is the same as this dot and that dot. All right, so what is IN? We know from Ohm's law. I'm not going to rederive it for the 17th time. It's the voltage drop across RP divided by RP. This is just Ohm's law rewritten as I equals delta V over R. Okay, well, what is the voltage drop across RP? We see that if we go this way, we get 3 volts. If we go this way, we get 0 volts. There's no resistor in between, so we know the voltage drop across RP is 3 volts. And RP we know is 63.46 ohms. And when we calculate that out, we get 0.0473 amps. Sorry, that doesn't look super nice. Okay, and just like before, I like to give it in terms of milliamps as well. You don't have to do this; it just makes the check as we go along easier. Okay. All right. So that's step 4, and so far we're not able to write down anything special about this, but we're going to need this current. Okay, we're not able to use this current. This is not an answer. This is not the current through any of our resistors up here, but we're going to use this to find that out as we go back up. Okay, so step 5 is going to be to figure out what is the current going through these two here. Well, we know that the voltage drop across this the delta V 50/60, if you will, we know that voltage drop is 3 volts. Okay, and we know that because I can go straight from my resistor all the way to the battery, and straight from the other side of my resistor go all the way to the battery, and those two potentials have to be the same. So those are 3 volts there, and I do the same here. Delta V 70/80 is also 3 volts. Okay, so we know that voltage drop there and there. Okay, this is not our answer. We still have to go apply this, and whatever we find out about the current in here, we got to apply that to here. This is why physics is hard. So we have to have a lot of steps, and we check as we go. All right, so step number 5. Let's calculate what the current is through I-50/60 or 60/50, whatever we want to call it. So let's figure out what that current is. We know IN. We know that is 0. I'm going to use milliamps here, because we're going to use this as our check. Okay, there's our IN. And we know that IN is going to split, and this is going to be I 50/60 or 60/50, either one. And this I here is going to be I 7080. Things are getting really cramped in there, but they're the two currents, and they split from IN. So let's figure out what I 5060 is. We know that's going to be delta V 5060 over R 5060. Okay, delta V we know is 3 volts. R we know is 110 ohms. And when you do that, you get 0.0273 amps, which is 27.3 milliamps. Okay, we're going to apply the same thing. We're going to apply the same logic, right, to this current down here. I 7080 is going to equal the voltage drop across our 7080, which is 3 volts, divided by the resistance, which is 150 ohms. Okay, and that is 0.02 amps, which is 20 milliamps. Okay, so before we move on, let's check. Does this and this add up? Because these currents, they're in parallel, right? This is a parallel circuit. Currents in parallel have to add up. Currents in parallel add up, okay, to a total current. And so do these add up to our input current of 47.3? Yes, in fact, they do exactly. So far, we are looking great. Okay, check as you go. I can't tell you how important that is. So that's step 5. Step 6 would be our check, which we just did. IN, I'll do it for real, is equal to I 6050 plus I 7080. Oh, look at me, not using units. Okay, so yay. Again, they check out. All right. Step number 7. Okay, so we've found everything we can out about this guy here. We know the voltage drop is 3. We know the voltage drop here is also 3 across this one. What are we going to use when we bounce back up? Okay, well, we know I 5060 is 27.3 milliamps or 0.0273 amps. Okay, so we know that this current going into these two resistors up here, notice I've gone back to amps because I'm calculating now, not just checking. Okay, and we know that the current going through the 7080 is, what did we say it was? It is equal to a 0.02, oops, sorry, 0.02 amps. Okay, and that's what we know. We don't know the voltage drop across these two. We know the voltage drop across both of them is going to be 3 volts, but we don't know what it is across each one. If these two resistors happen to be the same, 50 ohms and 50 ohms, then we could just divide that voltage by 2. The resistors divide the voltage. So here it's going to be a percentage, right, of that 3 volts, but we'll calculate it here in just a bit. Okay, so step number 7 is let's find out what that voltage drop is. Okay, let's find out what the voltage drop is across our two resistors here, 50 and 60. So delta V 50 is equal to R 50 times the current, and the current, again, going through both of these, we called it 60-50 or 50-60. And It's 50 ohms. I'm running out of room. Sorry. 0.0273 amps. Oh, I'm so sorry about that. Here, I can't do that. I can't do that. It's killing me. All right. So, again, I say it 1,000 times. Showing your work clearly, neatly is really important. So we have 50 ohms. Let me straighten up the screen. Times our current going through this is 0.0273 amps. And what ohms times amps is 1.365 volts. Okay, so that's what V50 is. And now we're done with that one. Look at that. We've found one answer finally. Okay. We can also show that I50, the current going through the 50 ohm resistor, is 0.0273 amps. Okay, so we know that. And then delta V60 is going to be the same thing. It's going to be, I'll just go ahead and write it out because well, sure, I'm going to just write it out. It's the same equation as this. R50 is the same as R60. So it's going to be, sorry, that's not true. R50 is 50 ohms. R60 is 60 ohms. But our current, look at that, I did it again. Running out of room. Sorry, y'all. Delta V60 is going to be 60 ohms times the current, which is and when we do that out, we get 1.638 volts. So that's delta V60. And we also know that I going through the 60 ohm resistor is the same as the 50. So we are just racking up the answers here. Before we leave here, step 8 is to check our work. So we have resistors in series, and if we look at our equation sheet, the resistors in series add up to the voltage across both of them, across the total voltage in series. And we know that the voltage drop across both of them is 3 volts. Okay? That voltage drop is 3 volts. So let's check. Does this voltage, does delta V50 plus delta V60, does that equal to delta V50/60? Does it equal to 3 volts? And when we look at it, it sure as heck does. So, so far we are happy, we are moving on, and we know that so far all of our calculations are good. So we're feeling pretty good. We just have another step to go. We do the same thing that we did over here to calculate the voltage drop across the 70 and the 80 ohm resistors. All right, so this would be step number 9. And this is delta V of 70 is equal to R70 times I, and we call this I8070, or 7080. And so this is going to be 70 ohms times the current going into these two, which was this many amps, okay, 0.02 amps. And that product is 1.4 volts. Okay, so that's the voltage drop across the 70 ohm resistor. So we can box that because that's one of our answers. And we do the same thing for delta V80, which is 80 ohms times the same current, right? It's the same current, 20 milliamps, 0.02 amps. And when you multiply that out, you get 1.6 volts. Okay, so that's another answer we can box. We now know the voltage drop across our 80 ohm resistor. Yay. And the last step, is to check. Okay, so check our work. And we know that the voltage drop across both of these is 3 volts. And the voltage drop, again, these are series resistors in series. And so they add up. And hopefully 1.4 volts and 1.6 volts adds up to 3. And they do. And so we say, yay, they add up. Okay, and so that's it. Whew-wee, lots of work, but this is how it's done with what is a traditional way or a brute force way. Again, when you get into the next level of physics, you'll learn Kirchhoff's laws, which will give you some rules that you can solve without having to break it down. But this is a pretty good intuitive approach to what's happening, and you can see, the steps all along the way. What happens to the current? It branches, it comes together. Voltages add, voltages are equal. Currents add, currents are equal. You kind of really hammer home what the rules are. Anyway, that's it. Enough for me. That is, those are the answers for the homework. I hope this was helpful, and I'll see y'all later.